Bismillah Rahman Rahim. Assalamualaikum students. I am Sabir Hasnan, your science subject teacher from grade 8. In this lecture, we will discuss lever from chapter number 10, pressure and moments. Okay, now let's discuss lever and moments or movements. A force or a system of forces that may cause an object to turn or rotate, that is called movement. So in other words, a movement is a turning effect of force. Okay, so there are two results by the application of force. In the first case, let's suppose if we throw a cricket ball by applying force, that goes straight somewhere, okay, or if we kick a football that goes straight, it means in that case body moves straight by the application of force. Or if we push a car, we push a car, that car moves straight. But there is another way, there is another output in which by the application of force over there, by pushing or pulling, that object never moves along a straight line. In fact, that object starts rotating. So the force which rotates the body is called moment. What are the examples? A very simple example: opening a door. If we open or close the door, that by applying force, the door starts rotating. So this is called the turning effect of force. The force turns the door. Okay, the force rotates the door. Okay, so this is basically a moment. So moment is about a certain point, and moment may be clockwise or moment may be anti-clockwise. What does it mean, clockwise or anti-clockwise? If object rotate, the movement would be clockwise in such a way that it follow the clock. Okay, in a clockwise movement, body follow the clock wise, and in anti-clockwise direction, the movement will be anti-clockwise when that rotate opposite to the motion of a clock. Okay, I am discussing about analog clock. Okay, so in analog clock, if the rotation of a body, the movement turning effect of a body is like a clock, that is clockwise movement. If opposite to the clock, that is anti-clockwise movement. We can easily understand this concept by opening or closing the tab. Okay, water tab is an example of the rotation of the water tab, is an example of movements. By applying force, that can move clockwise or anti-clockwise. Either we open it or close it. Okay, so the point around which body or object rotates or turn is called pivoted point. We will discuss this point on next slide in a figure. Another name of movement is called torque. Okay, another name of movement is called torque. We can define the movement. There is another definition, and that is the product of force and moment arm is called moment or a torque. The product of force and moment arm is called moment or torque. Okay, so the formula is moment equal to force into distance. Okay, moment arm is actually a distance. Question is, what is moment arm? So the moment arm is actually moment arm is a perpendicular distance between the applied force and the pivoted point around which the body rotates. Let's suppose here we have a rod. Okay, this O is a pivoted point over there around which body rotates, and here we applied a force. Look, this distance and force, they are perpendicular to each other. This distance and force, they are perpendicular to each other. So this distance is called moment arm, and this point around which body rotates, O, is basically called pivoted point or pivot. Okay, so now what is the unit of moment or torque? You know, the unit of force is Newton, the unit of distance or this moment arm is meter, thus its unit is Newton into meter. Okay, so we can write it Newton meter. This is another example, and this example is related to the example of a spanner. So spanner is another example of a moment. Look at this figure. We want to open this or close this nut. Okay, whenever we want to open this or close this nut, so it will rotate, definitely rotate. So this point behaves like a pivoted point, and here is a spanner. So the length of a spanner is actually the distance or the moment arm. Okay, and here we will apply a force. Okay, look, it rotates anti-clockwise. It's opposite to the motion of a clock. So this movement is anti-clockwise. So whenever we apply a force, it rotates the object. Clear? Now if we take two different spanners, like a longer in length, okay, and a shorter in length, or so in case of spanner having longer in length, okay, we need a small force. A small force is required to rotate that object, okay, or this nut. In another case, if we use a short spanner having small in length, we need a large force. I told you the example of the nuts. If we whenever we open the nuts of a car wheel or the truck wheel, for the truck wheel we use a long spanner, and for a car wheel we use a small spanner. We can conclude we can easily open the truck wheel by using a long spanner. If we use a short spanner, definitely that need too much force, which is not possible, or in fact very, very hard to open all those nuts of a truck. Okay, now the spanner also acts as a lever. So what is lever? Lever is actually a simple machine consisting of a beam or a rigid rod pivoted at a fixed point. Okay, fixed point is called pivoted point, or in lever its another name is fulcrum. Okay, so lever actually helps to make work easier, and lever acts as a force multiplier. Why it acts as a force multiplier? Because by applying a small force we can lift a heavy weight. Okay, by applying a small force we can lift heavy weight. So a lever is another way of defining a lever. A lever is a rigid body capable of rotating on a point on itself. There is some point around which it can rotate. Let's try to discuss with the example. Here we have one example. Okay, on one side of this rod we have a heavy load. Here is the pivoted point or the fulcrum around which this rod moves or rotates, and here we apply the force on this rod or bar. So this force is the applied force acts as an effort. Okay, the applied force is called effort, and the weight which we can lift, okay, as an output is actually called load. Okay, and the point around which this lever moves or rotates is called pivoted point or fulcrum. So here we have pivoted point or fulcrum. Understand? Although there are three different classes of lever, okay, class 1, class 2 and class 3, but here we will only discuss the first one, in which the fulcrum or the pivoted point is at the center. Okay, look the example of scissor. Fulcrum is at the center. Applied force on one end, applied force on one end of, here we have applied force, and here is we have load. Okay, the other end of scissor it behaves like a load. So this over there load, we have load. Okay, so thus the conclusion is, in case 1 or class 1, fulcrum or pivoted point is at the center, applied force or effort is on one end, and the load is on the other end. The remaining two cases are second class and third class are here, in which they have different combinations. Now at last, movement in balance and principle of movements. The principle of movements or the movement in balance means, the principle of movement states that when a body is balanced, the total clockwise movement about a point is equal to the total anti-clockwise movement about the same point. Look at this figure as an example. A person sitting close to the pivoted point of fulcrum, having weight 1000 Newton, okay, and its moment is, let's calculate its moment or torque. 1 into 1000, the answer would be 1000, and it moves clockwise. But the person whose weight is less as compared to the person A, the weight of person B is less, that is 500, or in other word 50 kilogram around, and it is 2 meter away from the pivot. He is 2 meter away from the pivoted point. Okay, so if we will calculate its movement, 500 into 2, it gives us 1000 again, and its movement is, his movement is counterclockwise or anti-clockwise, because it moves opposite to the clock. So the movement, clockwise movement in case for person A and anti-clockwise movement for person B, they are equal in magnitude. This is called the movement in balance or principle of movements. Over there, anti-clockwise movement or anti-clockwise torque equal to the clockwise torque. I hope you learned a lot from this video. Thank you very much. Stay blessed.